Welcome back, fellow developers. Today, we're diving straight into another explainer where we take complex topics and break them down into completely actionable insights that you can start using right away. Today, we are talking about your code, your peace of mind, and how to seamlessly integrate proactive security into our daily routines. We're going to completely transform the way you look at building software. 80%. Now, I really want you to let that number sink in for just a second, because this isn't just some random, made-up statistic. This is the staggering percentage of security vulnerabilities that you can catch and neutralize before you write a single line of code. Just imagine that, eliminating 4 out of every 5 potential security disasters before you even open up your code editor. That is the absolute power of what we're discussing today.
Because let's be real, we've all been there, right? That painful, totally heart-pounding scramble to fix a live vulnerability in production at, 2 a.m.? It is incredibly stressful, it's urgent, and it's a massive time sink. Now, I want you to contrast that nightmare with catching it early. Catching it early is peaceful. It's proactive mapping. It's basically a planned afternoon at a whiteboard with a cup of coffee, casually charting out threats before they ever even exist in reality. It's just a completely different way of living as a developer, you know?
So, here's our quick roadmap for today's explainer. We'll cover the 80% advantage, why developers own security, the 6 steps of protection, spotting threats with Stride, and finally, making security a habit.
Okay, let's dive right into Section 1, the 80% advantage and why we need to shift our mindset.
So to actually hit that massive 80% reduction in vulnerabilities, we have to fundamentally shift our mindset to the absolute earliest stages of the development lifecycle. And that shift is called threat modeling. Basically, it's a proactive mapping process for finding and fixing potential security issues early, rather than treating them like a reactionary patching task later on. I really want us to stop looking at security as this tedious, end-of-the-line InfoSec chore. Threat modeling is a massive strategic advantage. Think of it as a design tool that literally makes you a vastly superior architect of your own systems.
Moving right along to Section 2, why developers own security and why we are the ultimate first line of defense.
You know, stepping up to that responsibility is actually really empowering. When we own security from day one, we catch issues before they morph into catastrophic problems. We save an unbelievable amount of time and effort by addressing risks early, and ultimately, we build deep, lasting user trust with secure applications. Embedding security from the very start, it just saves us massive, massive headaches down the road.
All right, Section 3, the 6 steps of protection. This is the core developer methodology.
So here are the 6 simple steps of threat modeling, designed specifically for us as developers. Understand the system, spot threats, list important parts, look for weak spots, fix risks, and test fixes. It's a structured, totally repeatable process. Let's go ahead and break these down one by one.
Step 1 is honestly all about communication. You have to really understand your system. You do this by creating a simple map showing your application's boundaries, the key features, and exactly where all that sensitive data lives. And crucially here, talk to your team. Seriously, you cannot do this in isolation. You absolutely need collective knowledge to ensure no critical component slips through the cracks.
Which naturally leads us into Section 4, spot threats with Stride, basically asking the big question, what could go wrong?
This brings us to a really brilliant mental framework called Stride. Let's walk through it. S is for spoofing. Could someone pretend to be a legitimate user by, say, forging a JWT? T is for tampering. Could your payload data be maliciously altered while it's in transit? R is for repudiation. Could someone perform a shady action and then just delete the audit logs to deny they ever did it? I is for information disclosure. Could private user data be accidentally exposed in a loose API endpoint? D is for denial of service. Could an attacker overload your system and take the whole thing offline? And finally, E is for elevation of privilege. Could a regular user somehow manipulate a role flag and suddenly gain full admin access? By running your system through this specific lens, you systematically uncover harms you might have completely missed otherwise.
All right, once you've identified those threats, we accelerate right into Step 3, list important parts. You must track your data flow. Follow exactly how sensitive data moves through your databases, across your APIs, and past your authentication layers. Tracking this flow is exactly how you spot those specific choke points that are going to need some extra armor.
Next up is Step 4, look for weak spots. This is where you literally put on your hacker hat and relentlessly hunt for vulnerabilities. Look deep into your code and your infrastructure. Are you running outdated NPM packages? Do you have weak cloud configurations straight out of the box? Are there missing security checks on your endpoints?
You absolutely have to stay constantly updated on the latest risks targeting your specific tech stack.
Which brings us to step 5. Fix the biggest risks. Now, here is a fundamental truth of software engineering. Not all risks are created equal. You have a finite amount of time, right? So you must logically focus your energy on fixing the vulnerabilities that would cause the most massive damage first. Securing exposed APIs or encrypting highly sensitive user data, yeah, that should always be at the very top of your priority list.
And finally, step 6, test your fixes. Look, you cannot just write a fix and assume it holds water. We must verify. Run your vulnerability scans in your CI/CD pipelines, conduct rigorous peer-PR reviews, and crucially, create an incident response plan. You have to practice handling problems in a safe environment way before those problems ever go live in the real world.
Bringing it all home with Section 5, making security a habit for long-term application.
So the absolute crucial point here is that threat modeling is a regular routine. It is not a one-time task. You don't just do this once at the kickoff of a massive multi-year project and then never look back. Every sprint, every new feature, every architecture change, this process needs to be a completely ingrained habit in your development workflow. Honestly, that is the only way it truly saves you time in the long run.
To tie this whole shebang together, I love this quote. By adopting threat modeling, we proactively reduce vulnerabilities, streamline the development process, and build trust with our users. When you do this, you are shifting from being just a passive writer of code to an active guardian of user data.
I want to leave you with this final, somewhat provocative challenge. Will you spot the threats, or will you let them spot you? Because every single time you sit down to build something new, you have a choice. You can wait for that 2 a.m. pager alarm to go off, or you can grab a whiteboard marker right now and take control of your software's destiny. Make the choice to be proactive. Thanks for joining me on this explainer, and I'll see you in the next one.